Hi, let's discuss on the topic probability. Exercise 15.1, page 283. Problem number 1. In a cricket match, a batswoman hits a boundary 6 times out of 30 balls she plays. Find the probability that she did not hit a boundary. Let E be the event of hitting the boundary. Then P of E will be equal to number of times the batswoman hits the boundary, the whole divided by total number of balls she plays, which is equal to 6 divided by 30. It is equal to 1 by 5 or it is equal to 0.2. Therefore, the probability of not hitting the boundary will be equal to 1 minus the probability of hitting the boundary. This is equal to 1 minus P of E, that is 1 minus 0.2, which is equal to 0.8. Problem number 2. 1500 families with 2 children were selected randomly. The following data were recorded. So, number of girls in the family versus the number of families are given. Compute the probability of a family chosen at a random having 2 girls, 1 girl, number 3 no girl. Also check whether the sum of these probability is 1. Number 1, total number of families we have to find. That is 475 plus 814 plus 211, which is comes to 1500. Problem number 1, you have to find for 2 girls. So probability of a family having 2 girls is, so that is given to be 475 in the table divided by the total number of families. It's equal to 19 by 60 is the answer. Number 2, probability of a family having 1 girl will be, from the table we have it as 814 divided by total number of families 1500, which is equal to 407 by 750. Number 3, probability of a family having no girl will be 211 divided by 1500. So the sum of these probabilities will be equal to 19 by 60 plus 407 by 750 plus 211 by 1500 is equal to 475. Taking LCM is 1500, 475 plus 814 plus 211. It comes to 1500 by 1500, which is equal to 1. Hence, the sum of these probabilities is checked. Question number 3. In a particular section of class 9, 40 students were asked about the months of their birth. The following graph was prepared for the data so obtained. Find the probability that a student of the class was born in August. So according to the bar graph given, first we need to find the total number of students born in the year. So from the bar graph we can write for January it is 3, for February it is 2, and so on. So 2 plus 2 plus 5 plus 1 plus 2 plus 6 plus 3 plus 4 plus 4 plus 4, which comes to 40. So we need the number of students born in August is 6. Therefore, the probability that a student of the class was born in August is 60 by 40, which is nothing but 30 by 20. Problem number 4. 3 coins are tossed simultaneously 200 times with the following frequencies of different outcomes. And outcome versus frequency table is given. If the 3 coins are tossed simultaneously, again compute the probability of 2 hits coming up. Total number of times the 3 coins are tossed comes to 200. So number of times when 2 hits come up is 72 from the table given. So therefore the probability of 2 hits coming up is 72 by 200, which is equal to 9 by 25. Question number 5. An organization selected 2,400 families at random, surveyed them to determine a relationship between income level and the number of vehicles of a family. The information gathered is listed in the table below. Suppose a family is chosen. Find the probability that the family chosen is number 1. Earning rupees 10,000 to 13,000 per month and owning exactly 2 vehicles. Now we have the total number of families selected to be equal to 2,400. Now what is asked is question number 1. So number of families earning rupees 10,000 to 13,000 per month and with 2 vehicles. Will be 29 from the table. So therefore the probability will be 29 divided by the whole value 2,400. Question number 2. Similarly, the number of families earning rupees, question is earning rupees 16,000 or more per month and owning exactly 1 vehicle. So number of families owning 1 vehicle and earning rupees 16,000 or more is 579. That is the last one, divided by 2,400. 579 is the last in the table. So the 193 by 800. Question number 3. Earning less than rupees 7,000 per month and does not own any vehicle. So number of families earning less than rupees 7,000 per month and not owning any vehicle is equal to 10. So therefore the probability will be 10 divided by 2400, which is equal to 1 by 240. Question number 4. Number of families earning between 13,000 to 16,000. So 13k to 16k per month and owning more than 2 vehicles will be equal to 25, which is equal to, the probability will be 25 by 2400, which is equal to 1 by 96. Problem number 5. Owning not more than one vehicle. So number of families owning 0 vehicle plus number of families owning 1 vehicle. From the table we have it as 10 plus 0 plus 1 plus 2 plus 1 plus 160 plus 305 plus 535 plus 469 plus 579, which is equal to 14 plus 2048, which comes to 2062. So probability will be 2062 divided by 2400, which is equal to 1031 by 1200. Problem number 6. The tabular column is given against the marks out of 100 and number of students. Number 1. Find the probability of that a student obtained less than 20% in the mathematics test. So the total number of students is 90. Number 1. Number of students who obtained less than 20% in the maths test is 7. So therefore the probability will be 7 divided by the total students 90. Problem number 2. Find the probability that a student obtained marks 60 or above. So number of students obtaining marks (60 or above) will be equal to 15 plus 8, is equal to 23. So therefore the probability will be equal to 23 divided by 90. Question number 7. To know the opinion of the students about the subject statistics, a survey of 200 students was conducted. The data is recorded in the following table. Opinion versus the number of students. So find the probability of a student chosen at random likes statistics. Number 1. Number of students who likes statistics is 135. Therefore, the probability that a student chosen at random who likes statistics will be 135 by 200, which is equal to 27 by 40. Question number 2, who does not like it? So number of students who do not like statistics is 65. Therefore, the probability of a student who is chosen at random who does not like it will be 65 by the total value 200, which is equal to 13 by 40 is the answer. Question number 8. The distance of female engineers from their residence to their place of work were found as follows. What is the empirical probability that an engineer lives? Question number 1, less than 7 km from her place of work. Total number of female engineers is 40. So number of female engineers whose residence from the place of work is less than 7 kilometers is 9. Therefore, from the given values, therefore the probability that an engineer lives less than 7 kilometers from the place of work will be 9 by 40. Question number 2, more than or equal to 7 kilometers from her place of work. So number of female engineers, the distance in kilometers, whose residence from the place of work is more than or equal to 7 kilometers is 31. So the probability will be equal to 31 by 40. Question number 3. Number of female engineers, their distance whose residence from their place of work is within half kilometer is none, so it is 0. The probability that the engineer lives within half kilometer distance from the place of work will be 0 by 40, which is equal to 0. Question number 9 and 10 are activity based. So let's move on to question number 11. 11 bags of wheat flour, each marked 5 kg, actually contain the following weights of flour. The values are given. Find the probability that any of these bags chosen at random contains more than 5 kg of flour. The total number of bags of wheat flour is 11. Number of bags of wheat flour containing more than 5 kg of flour is 7. So therefore the probability of the bags having more than 5 kg of flour is nothing but 7 divided by total number of bags, that is 11. Question number 12. A study was conducted to find out the concentration of sulfur dioxide in the air in parts per million ppm of a certain city. The data obtained for 30 days is as follows. The values are given. You are asked to prepare a frequency distribution table regarding the concentration of sulfur dioxide in the air in parts per million of a certain city for 30 days. Use this table, find the probability of the concentration of sulfur dioxide in the interval 0.1 to 0.16 of any of these days. So total number of days is 30. Number of days on which the concentration of sulfur dioxide was in the interval 0.12 to 0.16. On any of these days will be 2. So 2 divided by the number of days, or which is equal to 1 by 5. Now we will have to give the table. So let this be the concentration of sulfur dioxide in parts per million. Now let be the tally marks. This be the number of days. 0.00 to 0.04, 0.04 to 0.08, 0.08 to 0.12, 0.12 to 0.16, 0.16 to 0.20, 0.20 to 0.24. Tally marks will be, this will be 4, 1, 2, 3, 4. This will be 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. The fifth value will be crossed always. Next will be 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Next will be 2, next will be 4, next will be 2. So this is the chart. Moving on to problem number 13. The blood group of 30 students of class 8 are recorded as follows. Represent the data in the form of frequency distribution table. Find out which is the most common and which is the rarest blood group among those. So total number of students is 30. Number of students having blood group AB is 3. Therefore, the probability, so students selected in random having blood group AB will be 3 divided by the whole class, whole students, which will be equal to 1 by 10, which is equal to 0.1. Frequency distribution table will be, this is the blood group, tally marks, number of students, group A, group B, group AB, O. This will be 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. This will be 6, 1, 2, 3, 4, 5, 6. This will be 3. This is 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now the total value is 30. So this is the frequency table.